The universe contains about 100 billion galaxies. Each of those galaxies contains about 100 billion stars. Many of those stars have planets orbiting them. So how do we look for life in all that immensity? It's like searching for a needle in trillions of haystacks. We might want to focus our search on planets that we know can support life as we know it, what we call habitable worlds. Because of its unique chemical and physical properties, water is absolutely essential for all life as we know it. And so we get especially excited about other worlds on which water is abundant. Fortunately, water is very common in the universe, but life needs water in the form of liquid, not ice and not vapor, and that's a little bit less common. For a planet to have liquid water at its surface, 3 things are important. First, the planet needs to be large enough that the force of gravity keeps the water molecules from flying off into space. For example, Mars is smaller than Earth and so has less gravity, and that's one important reason that Mars has a very thin atmosphere and no oceans at its surface. Second, the planet needs to have an atmosphere. Why? Because without an atmosphere, the planet is in a vacuum, and liquid water isn't stable in a vacuum. Third, the planet needs to be at the right distance from its star. Too close, and the surface temperature will exceed the boiling point of water, and oceans will turn to vapor. Too far, and the surface temperature will fall below the freezing point of water, causing the oceans to turn to ice. A perfect zone where water stays liquid looks kind of like a belt around the star. We call that belt the habitable zone. The planet isn't necessarily habitable just because it's in the habitable zone. Consider the planet Venus in our solar system. If you were an alien astronomer, you'd think Venus is a pretty good bet for life. It's the right size, it has an atmosphere, and it's in the habitable zone of our sun. But Venus is not habitable, at least not at its surface, not by life as we know it. It's too hot. That's because Venus's atmosphere is full of carbon dioxide, an important greenhouse gas, and is almost 100 times thicker than our own. As a result, the temperature on Venus is hot enough to melt lead, and the planet is dry as a bone. So finding planets of the right size and distance from their stars is only a beginning. We also want to know about the makeup of their atmospheres. And what about life as we don't know it, using a liquid other than water? Maybe we are the crazy creatures living in an unusual and extreme environment. The only way to find out is to go out and explore.